Today I'm doing Surds with you. Can you see these three questions? I'm going to do all three in this video. And number 3 looks like a popular exam question that I've seen. But let's do everything so we understand. Question number 1. And the question is, you have to simplify this and leave the answer in the simplest surd form. Step number 1 is, do you see this 12 here underneath the roots and the 75 over there? I'm going to rewrite them. I'm going to rewrite them as two numbers, something times something. But one of these numbers must be a perfect square. Perfect squares, 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, and so forth. The square root of 12 will become 4 times 3. Can you see? I'm multiplying two numbers, but one of them is a perfect square. Plus 4 times 75 can be written as 25. That's a perfect square times 3. So that's step number 1. In my next step, I'm going to say, there's a rule that says if you multiply two numbers under a root, you can actually split them up like this. So you can go from this to this, or you can go from this back to this. So I'm going to use this. Can you see? Here it is. I'm going to split that up. This will become root 4 times root 3 plus 4. And then I'm going to split this up. So this will become the square root of 25 times the square root of 3. Then in my next step, I'm going to ask myself, can't I work one of these roots out? I can without a calculator, this one and this one. The rest will stay the same. The square root of 4 is 2 and this is root 3. This is a 4. The square root of 25 is 5. This is root 3. So before I add like terms, can you see that I can multiply these two first here? So then I have 2 root 3 plus 20 root 3. Okay, then in the last step, I want you to just think of this. Let's say you had 2x plus 20x. The answer would be what? 22x. Because they are like terms, so you just add the numbers. You must now apply that same principle to surds. Here's the like terms. 2 root 3, that's the x. Plus 20 root 3, that's the other x. They are like surds. Will give me 22 root 3. Let's look at number 2. I'm going to apply the same principle. So do you see this 48? You can rewrite it. This 27, you can rewrite. Again, I'm going to write it as something times something, but one of the numbers must be a perfect square. So 1, 4, 3 times 3, 4 times 4, 5 times 5, and so forth. The square root of 48 can be written as 16. So 16 times 3 minus root 3 stays root 3 over 27 can be written as 9 times 3. So then 27 can be written as 9 times 3. That's your first step. Step number 2, I'm going to break these things up. I can break this one up and I can break this one up. This will stay the same. I'm going to say break up, minus root 3. Then break up again, break up, break up. After I've broken up, I'm going to ask myself, isn't there a root I can work out? You can. The square root of 16 and the square root of 9. So let's go. The square root of 16 is 4 root 3 minus root 3 over the square root of 9 is actually just 3 over root 3. So far, this is the question. Now, I want you to imagine again. If this was 4x minus 1x over 3x, can you see these are the x's? I'm just making an example. Let's take them away. How would you do this question? So we're going to apply that same principle here. 4 root 3 minus 1 root 3 is 3 root 3 over the 3 root 3 that was there. And this, anything over itself, gives me 1. That's how you do number 2. Number 3, the last question that we're doing, is this exam kind question. Okay, let's look at this question, grade 11s. With this question, the first thing I would do is I would break it up. This is 4 times x to the 9. So it's actually this. It's something times something. Can we do? We can break it up. I'm going to break up. I'm going to say it's this times this. There, I've broken it up. Then I'm going to say, let's break the other one also up. So it's this times that. So even here, it's this times that. Okay, and then at the bottom, it's only root x. So here's root x. So that's step number 1. I break it up. Then, where can I get answers? So I can work out this and I can work out this. That's easy. I can also work out this and I can work out that. And I can work out that. Let me show you. The square root of 4 is 2. So the square root of 4 is 2. Then the square root of x to the 9 becomes x, the inside power over the invisible 2 that's there. So this is a square root. If there's nothing, it's a square root. So we write it as inside over outside. Minus the square root of 16 is 4. X to the inside over outside. Inside over outside. Then the square root of x is x. If there's no power, there's an invisible 1. And if there's nothing outside the root, there's a 2. So this is inside over outside. So that's step number 2. Then, do you notice grade 11s? This is the same as this. So they are like terms. It's almost like if you had 2k minus 4k. What would the answer be? The answer would be negative 2k. So this is the k and this is the k. So for 2 minus 4, 2k minus 4k. It's just, we are not working with k. It's negative 2, but the k is this. That's the k. Over x to a half. From here, we do normal algebra. A negative over a positive is a negative. 2 over 1, there's an invisible 1, is still 2x. When the base numbers are the same and you divide, you minus the powers. So that means top minus bottom. So this will give you 2x to the 4. And that is the answer. Well done.